Good morning, everyone, or good afternoon, I guess. Yep. All right, we'll go ahead and get started. So today, we're looking a little bit more closely at basically the market for physicians. Last time we were talking about the supply, and we're still on that theme for sure, but now we're starting to think less about the details of costs and things and more about how physicians interact and supply medicine in the marketplace. Um, right. So looking at the interactions between um, other firms, right? A physician firm and other firms, in terms of competition, as well as the interaction between physicians and patients within the marketplace. Okay, so quite a few learning goals for this chapter. First of all, you want to be able to identify how doctors choose to locate their medical practices in a spatial equilibrium. And so we're going to talk about something called the hotelling model, which is a spatial model of economics. You also want to be able to master the concepts of monopolistic competition, because that's how we are going to model the physician firm is as a monopolistically competitive firm. So obviously not perfect competition, but not exactly oligopoly or monopoly either, right? So some competition, but also some market power, right? And then also being able to understand how the medical services market, or I'm sorry, how the competition within monopolistically competitive firms and the medical service market sort of work, and how prices and output of each physician firm are set in these types of markets. You also need to be able to follow the role of consumer search and how it affects the physician services market. Understand how advertising and licensure affect these markets. So obviously doctors have to be licensed, so that's going to have an impact in the market. And then thinking about advertising, right? Because advertising is an important aspect of monopolistic competition. So hopefully you'll start remembering some things from your micro courses about monopolistic competition. And one of those things is the important role of advertising and trying to differentiate your product, right? So remember, product differentiation is pretty important. Be able to grasp the distinction between market level demand and a specific firm. So this is really just more review of monopolistic competition. I'll pause my video for a minute. Unstable. You should also be able to explore the world of demand. So we've talked about induced demand a little bit. So we're going to look on it here in this chapter towards the end of the chapter. And your goal is to be able to examine various studies that show the extent of in various settings and critique the quality of this. Okay. So for the most part, we are only going to cover probably the first two today. The rest of them we will cover next week, hopefully all of them next week. All right. So in this chapter, there's really three main issues or three main questions that are addressed. Where should a doctor locate his or her practice? It's a pretty important decision. And in some ways, it's kind of like the decision to specialize, and we'll see how that's true. Another question that's addressed here is, how are doctors and patients matched with one another? In other words, how do they come to interact in the market for medical services? And then the last question that we're addressing is what role does information play in the interaction between doctors and patients? So things like induced demand and other issues come about when answering that question. So we're going to start with the first one and then start to get into the second one. So first of all, we're thinking about the location decision. And again, this, like I said, this comes from Hotelling's location model. This is an old model. This is from back right before the Great Depression. So it's quite an old model, but it's still widely used and very well respected. And the typical example when learning the Hotelling model is an ice cream vendor's decision on where to place their cart on a public beach. And so the problem is pretty simple if there's just one vendor, right? They basically place themselves in the middle of the beach. And typically there's like a span of beach, like maybe a mile or so of beach. And so if there's only one vendor, they place themselves right in the middle, right? And a big part of this model is the consumer's cost of travel, right? So the business is actually considering how much it costs the consumer to travel to that location. When there's one vendor, it doesn't really matter that much. But obviously, if the vendor placed themselves at one end of the beach, then people on the far other end of the beach would have a very high travel cost, right? And so it's possible that some of those customers wouldn't travel all the way to the other end of the beach to get some ice cream. And so in order to try to capture those customers, it's better to locate in the middle, right? Basically cutting those customers' travel costs in half, right? But then the problem becomes more interesting as there's more and more vendors, right? And basically what happens is in equilibrium, the vendors are equally spaced and they each serve exactly the same number of customers. Of course, that's assuming that the beach is like uniformly distributed. There's the same number of people in each space along the beach, right? Right. So that's the resulting equilibrium. So we can think of the same thing with doctors, right? Doctors, it should, if Hotelling's model applies to doctors, then what we should find is that doctors are more or less spaced out so that they each have roughly the same number of patients, or I guess not patients, population. I think that's a typo. That should be population. So that's what Hotelling's model would predict, right? That's the prediction. So we can think of, instead of a beach, maybe 3 cities that are kind of close to each other, right? And this is what we see in table 7.1. So let's take a look at it. Okay, so the example here is that there's 3 different cities, each with different populations. And then we have 2 columns with a different number of doctors. Okay, so in the first column, there's only 12 doctors. And basically, the doctors, if Hotelling's model applies, the doctors are going to locate where they basically each have the same number of patients or the same population, right? So in city A, doctors, 10 of them would go to city A, 2 of them would go to city B, and none would go to C. And that's because basically, as a doctor, if you're looking at the situation, right, like let's suppose that you're the marginal doctor, right? You're the 13th doctor and you're trying to decide where to go. And you see that in city A, there's 10 doctors. And so that means that there's a doctor for every 10,000 people, right? And so if you went to city A, you would have a market of more than 5,000 people. So you wouldn't go to C, you would go to A or maybe B, right? In fact, I think you would go to city, let's see, what's 100,000 divided by 11 is like 99,000 roughly. And then 20,000 divided by 3. So yeah, if you're the marginal doctor, you would definitely go to city A because you would have the biggest share, you would have the biggest population at your disposal in terms of demand. Um, and in fact, it would take 25 doctors for there finally to be a doctor that chooses to go to C, right? And in that case, there's one doctor per 5,000 people. But it takes that many doctors to finally have a doctor decide to travel to and locate in city C. All right, does that make sense? Okay. Now this is all this is all theoretical, right? We haven't looked at any evidence yet. So, um, but again, city C only attracts a doctor once there are more than 24. So there fortunately is some evidence on this. Some of the first evidence on this issue came from a natural experiment that was conducted by some US medical schools in the 1970s. And basically, what was going on at that point of time, we've already seen this actually, medical school enrollment doubled and international students started to pour into the US as a result of the perceived shortage of doctors, right? And as a result of that, the number of active doctors per 100,000 people actually increased by 50%. And we can use this natural experiment to examine where doctors chose to practice medicine and how that choice changed in response to this huge new group of graduate students, right? This huge new group of medical graduates. So basically what we're going to do is we're going to compare the year 1970 and 1979. But first, let's think about a couple of extremes. So there's one extreme uh, model, I guess, um, that hypothesizes that, well, maybe doctors place themselves in the most lucrative locations and they try to induce as much demand as possible in order to remain happy or content, right? And then the other, well, okay, so let me not jump ahead of myself here. The problem with that, though, is that it requires that the doctor has essentially an unlimited ability to induce demand, right? Basically stealing customers from other doctors, right? So that's a pretty extreme possibility, and it's not something that's supported by the evidence. The other extreme, which is more like Hotelling's model, looks like Table 7.1, right, where the city C doesn't get a doctor until there's 25 doctors, right? Now, what would this look like in the evidence? What would we be looking for in the data? Well, this type of model, Hotelling's model, would reveal itself in a way that shows us that as there are more doctors, areas that don't have doctors suddenly do have doctors, or areas that have a low number of doctors are getting more. Okay, so let's see if we find that evidence. Um, so the truth of the matter, though, is that most small towns have at least one doctor. There's almost no towns that have zero doctors, so we should keep that in mind. But nevertheless, this spatial competition should still play out, especially when thinking about specialists, right? Most cities and towns have like a primary care physician, but a lot of small towns don't have like a neurosurgeon or an orthopedic surgeon, right? So we really should be able to see this evidence, if it exists, within specialties, right? And in fact, that's exactly what we find. The results correspond closely to that expected by the Hotelling model. And this is evidence from Schwartz et al. And Newhouse et al. And what they found was that the diffusion of specialists into small towns occurred only when the total doctor to population ratio became sufficiently high. All right, so let's see what we mean by that. All right, so this is the table in your book 7.2. And it's kind of an interesting table. It's not really one that it's not like one we've seen before. So it's the percentage of communities that have non-federal physician specialty services in two different years, 1970 and 1979. Okay, so it breaks it down by specialty. So, you know, kind of the most basic is general and family practice. So like a general practitioner. And then it gives us the number of full-time equivalent physicians in the 23 sample states. And then the next column is cities of different sizes. So cities with different size populations. So the first column there is cities that are between 2.5 and 5,000 people. The next column is 5,000 to 10,000 people, and so on. And then the numbers down below are the percentage of those cities that were sampled that have at least one of these types of doctors, right? So you can see that there's lots, most small towns, right? 2.5 to 5,000 people, most of them have a general practitioner, right? In 1970, almost 90% of them had a general practitioner. For some reason, it fell in 1979. I'm not sure why, and then as you can see, like as cities get bigger, more of them are covered by at least one general practitioner. And as soon as you get to cities that are 20,000 people or larger, all of them have at least one general practitioner. Okay, so that's how we interpret this data here. And then down below, we see different specialties, right? So internal medicine, let me get my highlighter out or my laser pointer, right? So we have internal medicine, general surgery, gynecology, psychiatry, et cetera, right? All right, so if Hotelling's model works, what we should see is that these smaller towns will see an increase. We will see more of them, a larger percentage of them having at least one of these types of specialists. And sure enough, that's the general pattern, right? So if we start by looking at internal medicine, the percentage of the small towns that an internalist went up, right? So small towns went from 17% of them having an internalist to 23%. Slightly bigger towns went from 40 to 52%. That pattern is pretty consistent all the way up until we get to these 100% ranges. And that's pretty much true across the board, right? General surgery, we see almost everywhere an increase except for here, although this may not be statistically significant, so always keep that in mind. But in almost every case, there's an increase, right? 3 to 9, 12 to 17, 28 to 40, right? Almost every single case, there's an increase, or at least not a decrease. Okay, so that's supporting Hotelling's model, right? This idea that doctors are choosing to locate themselves spatially based on the number of potential patients they could get, right? Okay, so some things to note here. In 1979, there were about 9 pediatricians per 100,000 population in aggregate, or about 11,000 people per pediatrician. And the spatial competition model would indicate that smaller towns, towns smaller than 11,000 people, sorry, the spatial competition model says that towns that are smaller than 11,000 people should not commonly be able to attract a pediatrician, right? Because doctors can go to other cities and have a larger demand base, essentially, right? And that's exactly what the table supports, right? If we look back to this table and we look at pediatrics, and we look at towns that are smaller than 11,000, we see that very few of them have pediatricians, especially when they're less than 10,000, right? So here's the 10,000 range, less than 10,000. And then as soon as we cross over 10,000, there's a pretty huge increase, right? From 25% to 68%. So that's exactly what the Hotelling model would predict. So that's just one example, but there's many, that pattern exists pretty much in every single specialty, right? So we could look at another example with neurosurgeons, right? There were roughly 65,000 patients per neurosurgeon in 1970. So if we go back to neurosurgeons, where are the neurosurgeons? I don't see them listed. That's weird. It's not even on here. Anyway, but again, the pattern is the same for basically all specialties, right? Yeah, I'm not sure where the neurosurgeons are in that table, but anyway. In any case, the pattern is basically shows up with all specialists. And basically what this provides us with is a good prediction of the size of a city that's needed to attract a doctor in a specific specialty, right? So if we just take the overall population to doctor ratio for any specialty for the country as a whole, that gives us a good idea of what size city is needed to attract that type of specialist. There was another study that was actually earlier that provides different but supporting evidence. So it's different evidence, but it supports the same conclusion. And what they found was that doctors and dentists tended to move from states with relatively low economic returns to those with relatively high economic returns. Um, and so that's, it doesn't maybe seem like that's Hotelling's model, but it basically is, right? That's the same motivating factor in Hotelling's model, right? Choose the location where you can make the most money. And that's exactly what this study found. And so what we can conclude is that, not surprisingly, hopefully, since we're all economists, is that market forces play an important role in determining the physician's location. Now, this whole problem or issue of location kind of brings up an important issue, and that's that, we would, it seems like these small towns are underserviced, right? They don't have enough doctors. In fact, some small towns don't have any doctors. And so as a society, we might want to try to incentivize doctors to go to these places, right? Well, there are programs that do that. And one of them, the main one, is called the Health Service Corps, not Corp. My aunt and uncle actually were part of this program. So they were both doctors, and they went to live on an Indian reservation in Arizona so that they would have their student loans forgiven. So that's how it works, right? The program works in a way such that if you voluntarily go to one of these small underserved communities and work there, I think you have to work there for 5 years, then your student loans are forgiven. And of course, as we've learned previously, medical students have a substantial amount of student loan debt. So it seems like this would be a pretty good incentive to get people to get doctors to move to small communities. But unfortunately, it has had very little long-term impact. So basically, as soon as the doctors' loans are forgiven and they've completed the program, they get the hell out of Dodge and go somewhere else. So it doesn't have a lasting effect, unfortunately. Hey, dog. No. Hey, get down. Hold on one second. Come here. All right, sorry about that. Okay. So a researcher, Held, 1976, looked at this issue and showed that rural areas with and without these health service corps placements were equally likely to have a primary care doctor, right? So the fact that an area had an HSC in place did not improve its probability that it had a doctor. So that's not good. Another study measured that a 20% retention at the original site and 20% at another rural site. So basically the same finding, right? Let's see, what does this mean? It basically means that I'm not actually sure what they're referring to with original site and another rural site, but basically it was the same type of evidence, right? This program is not helping keep doctors in these communities, right? Only 20% of the doctors that participate in this program end up staying in the small community, while the other 80% end up going somewhere else at the conclusion of the program. Another study found pretty similar results, only 12% retention on site after 8 years. So that's pretty terrible, right? Just a little over 10% of the doctors stay at their site after 8 years. And one other study found that only 1 in 6 HSC doctors remain on site after 5 years. So pretty much the same type of finding, right? And 2 more recent reports basically tell us the same story. Sempowski 2004 found that such programs can attract physicians to the areas, right? So their physicians are willing to go to those areas, but that the long run retention is essentially unsuccessful. So it's the same story over and over again, right? Pathman et al. 2004 found that physicians that were obligated by return of service programs stayed in rural areas at almost the same rate were not obligated. So it's not, again, these programs, while they are getting physicians come to the areas temporarily, it's not able to keep them there, which really is the goal. But I guess at the very least, these areas do have doctors, even though they may be novices, right? New doctors. So at least they have doctors, right? It's better than the alternative, which is no doctors. Okay, so that's, oh wait, we still have one more thing to talk about. So the last thing we have to talk about regarding location is its similarity to the decision to specialize, right? Which we've already looked at. So of course, again, not surprisingly, economic forces drive both the decision to specialize as well as the location decision. So that's a similarity. And in both cases, doctors are responding to these economic forces in systematic and predictable ways, which is great. We love that in economics. Let's predict the hell out of everything, right? And there's another similarity in terms of potential barriers to entry, right? So with specialties and locations alike, there are potential barriers to entry. And we can gain useful perspective on this by looking at rates at which medical residency training positions are filled by U.S. medical school graduates. So you can see what I mean in a second here when we look at the table. But this was a research study done by Ebel 2008, and they gathered data on the fraction or proportion of residency positions that were filled by U.S. medical graduates and plotted it against the average income in that corresponding specialty. And this is what figure 7.1 is showing us. And basically what they found was that there's a strong linear relationship between medical school graduate fill rates and each specialty's average income. Okay, so this should not be surprising, right? And the main idea here is that, right, we're looking at the percentage of positions filled by U.S. graduates, which means, you know, if we're looking at, say, here's number 1, right, family medicine, about $200,000 per year in income, and 40% of those residencies were filled by U.S. graduates, which means who filled the other 60%? If not U.S. graduates.
International graduates?
Yeah, international graduates. Yeah, exactly right. So what we're seeing here is that as the incentives given by the salary of the specialty, right? We see increasing salaries here given the specialty. A larger proportion of those residencies are filled by U.S. graduates. Now, why would that be? Why do you think that U.S. graduates fill more of the residencies for higher paid specialties? Think of the supposed quality differences between U.S. graduates and international graduates. And also think about the fact that there's basically a shortage of these residencies, right? There's excess demand for these residencies. So there's like waiting lists to get into these positions. And it seems like these more intensive specialties, right? Intensive in terms of the training, more of them are being filled by US graduates, right? So why do you guys think that is? Yeah, go ahead, Blythe.
There's a bias against foreigners like education levels when it comes to medicine. Like America just assumes that other countries don't have as good of doctors as we do.
Yeah.
So
Yeah, that's exactly right. That's exactly right. So since there's a shortage of these residencies, and there's this perception that US graduates are of higher quality, they are going to fill more of the higher specialty type residencies, whereas international students are going to be able to get into things that are less specialized, right? So that's pretty much what's going on here. Plus, you have to think about the fact, like, this, if your opportunity as an orthopedic surgeon is to earn somewhere around $450,000 a year, there's going to be a lot of graduates that want to get into that type of residency, right? The financial motivation is there. And that's true for US graduates as well as international graduates. So there's going to be a really high demand for these positions, and there's going to be a shortage of those positions. And since US graduates are perceived to be better quality, they're going to get more of those positions, right? A higher fraction. So. Okay, so there's a strong link here between the attractiveness of these specialties and the earnings potential that they provide, right? It's also showing us something else. It's also revealing to us that hospital-based and surgical specialties that garner significantly higher incomes than primary care practices are going to choose locations that are nearby hospitals, right? If the doctor needs a hospital in order to perform their specialty, then they're going to obviously choose locations that have specialties, right? And like I mentioned already, the specialties with the highest US graduate fill rates have strong excess demand, or there's basically a wait list, especially for the most prestigious programs. And even the weakest programs in these specialties fill at high rates for the overall fill rates. So pretty high demand. So. Let's see, I actually already mentioned that. So again, these, particularly for these doctors with specialties that require a hospital, so surgeons and those sorts of things, they're obviously going to they're going to have a strong preference to locate somewhere near a hospital, right? Now, it happened to be the case that early on in sort of American medicine, medical staffs on hospitals would say that, oh, we're closed, right? We're not allowing any more new physicians or their patients. But that has changed over time. And in areas where most or all of these hospitals were closed, right? So this is a barrier to entry, essentially. Entries of physicians was effectively stifled, or at least for specialties such as surgery and obstetrics. Obstetrics. I don't know how to say that word. Obstetrics. I think that's how you say it. Okay, so in a nutshell, right? Both the decision to specialize and the decision where to locate are driven by financial incentives, economic forces. And on top of that, there's some instances where they're actually closely connected, like this this hospital use issue, right? Where certain specialties need a hospital. So the actual choice of specialty is directly linked to choice of location, right? Okay, are there any questions so far? Everybody's good? Okay, cool. All right, so now we're gonna leave the issue of location, and now we're gonna start to think about the interaction between patients and doctors, particularly the search, consumer search, and arriving at a market equilibrium. Okay, so how are doctors and patients matched up, and then how is price determined? Well, you guys probably have a pretty good idea already. But let's begin with sort of the textbook competitive market scenario, right? Which, by the way, is not the correct model, but let's start with that. This is the easiest model, right? We simply calculate market supply and market demand by adding up individual supplies and demands, and price is determined by the intersection of supply and demand, right? Nothing crazy here. The usual supply and demand analysis, right? And within this context, we can also analyze the change of costs of production, and look at the change in costs of production on price and quantity. Now, the other important aspect of a competitive market is that price is taken as given by the market, right? We have price takers. So no individual consumer or individual seller has a significant ability to manipulate price, right? Everybody's a price taker. And in this type of environment, the choice is pretty simple, right? Suppliers can't control price, so all they have to do is choose how much to produce. And then same thing with consumers, right? They have no control over price. They just take price as given. And then given that price, they decide how much to consume at that price, right? Now, there's one other issue, and that's the issue of quality. And if we could accurately measure quality, then we would have a bit better analysis. And in that case, we would basically have a single market for each level of quality, right? So we would have a market for pediatricians, but then we would also have markets for pediatricians of low quality, middle quality, and high quality, for example, right? And those would be separate markets. But of course, we could only do that if we had an accurate and reliable way of measuring quality, which is hard to get at. But that's, that's competitive markets. That's really easy and straightforward, right? So let's see, maybe let's look at some data and see if what we see in the data corresponds with some of these characteristics of competitive markets, right? Well, if we look at box 7.1, there's quite a bit of contrast between what we observe in actual data and what we would expect given a competitive market. And one point of evidence is that there seem to be many different prices in a specific area, right? The competitive model predicts a single price. There's one price, everybody takes it as given, and that's it. But the evidence in box 7.1 is showing us that there's actually many prices for the same thing, which would suggest that, okay, maybe these types of markets are not competitive. And it could be that the difference in prices is due to quality, but there's such a broad dispersion, there's such a wide variety of prices that it seems that it's very unlikely to correspond with quality differences. And in fact, there are several studies that have shown that there are substantial price differences for the same good in the same geographic area. So really strong evidence that these types of markets are not competitive markets, right? There's another observation that kind of goes against the competitive market prediction, and that's that doctors seem to price discriminate. And that's only possible in markets other than purely competitive markets, right? It requires that the firm has a downward sloping demand curve. And in perfectly competitive markets, the demand curve is flat, right? It's not downward sloping. So since we see doctors discriminating on price, it suggests that they face a downward sloping demand curve and therefore cannot be part of a competitive market. So really, the better model is a model of monopolistic competition, right? And so as a bit of review here, monopolistic competition is characterized by sellers with a downward sloping demand curve, and that demand curve shifts inwards in two different scenarios, either when more sellers enter the market, right? Because when more sellers enter the market, they are basically splitting up the market demand among more businesses. And so each business's individual demand falls. Or it's because the market demand itself falls, right? So that's the two possibilities. So the monopolistic part of monopolistic competition is referring to the fact that there's a downward sloping demand, right? Just like a monopoly. And then the competition part has to do with the fact that there still is free entry and exit, so that if there's profits being made, then new firms are incentivized to enter. And if losses are being made, then that incentivizes existing firms to exit, and they can do so freely because it's competitive. One other characteristic is that in the long run, there's zero economic profit. And that's because of the competition, right? The free entry and exit. If there isn't zero profit, then there's going to be an incentive to either enter or exit, right? And that those incentives disappear once profit is zero, right? So hopefully you remember these things. This should be a review for y'all. All right, so some more review. We're going to look at table, or rather figure 7.2. Hopefully this chart or this graph looks familiar to you. It should be review. So again, the firm in a monopolistically competitive market faces a downward sloping demand curve and then has the typical cost curves, right? The U-shaped average cost curve and the U-shaped marginal cost curve. And in equilibrium, there will be entry by other firms until the demand curve for each firm is just tangent to its average cost curve. And in equilibrium, price equals average cost. But unlike a competitive firm, production does not take place at the minimum average cost. It's at some cost that's higher than the minimum average cost. Okay, so hopefully this will come rushing back to you, right? So this is what a monopolistic competition in equilibrium looks like. So zero economic profit, right? P exactly equals average cost. So there's zero economic profit. But it's not like perfectly competitive markets. In perfectly competitive markets, the price is equal to the minimum of average total cost. But since we have a downward sloping demand curve, price is going to be a little bit higher than that, right? So hopefully this looks familiar to you. Now, I'm just going to mention a couple other things, right? So suppose the demand curve was out here, okay? Now, in that case, the firm would be making a profit, right? In that case, what am I trying to say? In that case, price would be above average cost, right? Price would be greater than average cost, and so the firm would make a profit. But that's only possible in the short run, because if that firm is making a profit, then entrepreneurs on the outside are looking at this like, oh man, there's money to be made here. Let's get into this, right? And as new businesses get into this industry, the demand curve slowly shifts to the left because each business now has a smaller fraction of market share. And so their individual demand goes down, and it continues to go down until profits are no longer made, right? That's the dynamic. And then the opposite would be true if the demand curve is over here, right? In this case, the firm would be making a loss. And if they continue making a loss, eventually they're going to exit. And as firms exit, each firm that remains in the market now has a bigger share of market demand, and the market demand and the demand that they face shifts to the right, and that stops again when we get to zero economic profit, right? So that's the dynamics there over the long run. So this relates directly to the location decision, right? This entry and exit decision applies directly to location, right? Because a doctor might leave one area and go to another, in which case they're exiting the area that they're already in and entering a new area. And so this relates directly to the decision to locate, right? So when a physician sees that a market has above average economic potential, they enter that market, and otherwise they disperse themselves more or less equally around the effective demand in all other markets, right? Just like the hoteling model that we looked at earlier. Okay, so this is the monopolistic competition model. It's useful because it corresponds with the data that we saw earlier, right? Price discrimination, dispersion in prices, right? Those sorts of things. But there is still perhaps a better or more refined model. We might be able to go a little bit further still. So this new approach, and it's relatively new. It was created by a guy, an economist, McGuire, in the year 2000. But this new approach emphasizes the ability of the doctor to set the amount of care the patient consumes, right? So setting Q, the quantity, kind of like induced demand in a way. And this is true even if the price is determined separately by some other force other than the market. Maybe it's set by insurance or government. It doesn't really matter how the price is set in this model. What's important is that the doctor can basically prescribe the quantity, and the patient isn't choosing it themselves, right? And it's because of the asymmetric information or the asymmetric knowledge, right? So what McGuire did was bring together several issues that we've considered previously that revolve around the manifestations of a physician's superior information position, right? The fact that they have more knowledge about the situation than the patient. That's not present in the plain old vanilla monopolistic competition model. In that model, consumers are choosing how much to consume. In this model, the doctor is choosing how much the patient consumes, okay? So that's the main difference. But the doctor is limited to a degree by the patient, right? The patient has some idea about a minimum amount of net benefit, right? They go to the doctor and they have in their head some idea of the minimum amount of benefit that they're going to get from visiting the doctor. And the doctor is constrained by this, right? That's the constraint the doctor has. So it's not like the doctor can just say, okay, you're going to need 20,000 surgeries, right? The patient's going to be like, no, I don't. Like that's not going to provide me with the minimum benefit that I'm expecting, right? So it is a limitation for the doctor to induce demand, right? But like with any firm, the doctor is going to try to maximize profit. But again, they're limited by this expected minimum net benefit that the patient has. And there is a nice picture for this. So we'll see it in a second here. But the nice thing about this new approach is, wait, did we just go over this? I think I duplicated this on accident. Yep. Okay, here we go. All right, so this is what it looks like in a picture. So pretty similar in ways to monopolistic competition, right? We have a downward sloping demand curve. And we have a price. So right now we're just assuming that the price is given. Now, if it was the usual model, the consumer would choose to consume wherever price intersects their demand curve, right? So, down here at this level of medical care. But in this new model, it's the doctor that chooses quantity, right? So, for example, the doctor might choose X star, And the patient is okay with this as long as they get their minimum expected net benefit here, which is NB naught or NB zero. Okay, so this light gray area is the surplus that the consumer expects to get at a minimum. Now, if the doctor didn't choose the quantity for them, they would choose this lower quantity and they'd get these two gray areas in total as their consumer surplus. But the doctor is aware that they can actually extract some of this surplus and still get to a point where the patient feels like they got their minimum net benefit, right? And so the doctor is able to expand the amount of medical care to the extent that the patient still gets the minimum amount of net benefit that they require. Okay, so this black triangle here is a loss of surplus for the consumer, but it represents a gain of profit for the physician, right? And the black area exactly equals this dark gray area. So the patient would get this entire surplus, but then they're losing this black area, so subtracting this gray area, and they still end up with the minimum amount of net benefit that they feel that they deserve or should get, right? So this is a really interesting model, and it seems to more accurately represent what actually happens in the patient-doctor relationship. I'm sure you've been to a doctor before, and there's a lot of things going on here too, right? Again, it's pretty much all related to information. Um, you don't know how many pills of a prescription you should take per day, or how much, right? The doctor does. And so, and they basically tell you the quantity that you should take, or the amount of surgeries you should have, or those sorts of things. So this seems to really fit well with what we see in real life, in terms of the doctor choosing the amount of medical care for the patient. Okay, so just to recap here, I think I mentioned all these already, but we'll recap this. So again, doctors choose the price and quantity. Not always the price though, but they do choose the quantity, right? So there are some cases where maybe the government or an insurance plan chooses the price, but that ultimately doesn't really matter, right? The doctor gets to choose X. And if they're lucky, they also get to choose price. And they choose price and quantity in a way that maximizes their profit while still allowing the patient to obtain that minimum expected benefit, right? That's kind of in a way, it's kind of like a budget constraint, right? The doctor has to make the patient feel like they got enough value from the visit. So they can't just maximize profit without thinking about that, right? Now, like I said, the consumer would prefer a quantity that's smaller than X star. And as a result of the doctor choosing X star for them, they lose some surplus, right? As a result of the overconsumption, essentially. And the only way that the doctor can prescribe a higher quantity than what's optimal for the patient is because of their large informational advantage. So again, this is a lot like induced demand, right? So like I mentioned just a second ago, this has some pretty interesting implications for what's widely considered the doctor-patient relationship, okay? Very common phrase used in the medical industry. So these relationships can be really important in the doctor's ability to diagnose and treat a patient, right? If you go to the same doctor for years and years and years, then they can get a really good sense of the types of medical care that you need. They can be really aware of like when you're feeling ill and those sorts of things, right? Just because they know you, they have a strong relationship with you. So they can recognize changes in your appearance and your overall sense of well-being or happiness or depression, etc. And these characteristics can't be easily passed on to other physicians. You have a patient record, right? Your doctor keeps records on all of the visits you've had and all the procedures and drugs and everything. And yeah, they can hand that to another physician, but that can't that file, that patient file, cannot fully describe you as a patient. And so the fact that you have an ongoing relationship with a physician is really important in being able to diagnose and give you good treatment, right? And on top of that, this is more for the benefit of the doctor than the patient, but these relationships allow the doctor to know things about the patient's willingness to, say, stick to a treatment regimen, right? Um, and that can potentially alter the treatment choice in a way that enhances the patient's chances of a cure. So I guess this is still beneficial to a patient, but it could also be beneficial to the doctor, right? Um, as the doctor gets to know you, they know whether you're going to take your full prescription or not. They can also start to get an idea of like what you're willing to do. And so they may be able to induce more demand if they know that you're like, yeah, well, okay, doc, you know what's best. So I'll do whatever you say. Right. As opposed to a patient that's more like, well, I went on WebMD and I don't really think I need that. The doctors of what type of patient you are if you have a good relationship with them. So the good thing is that this model, this more refined model, operates this patient-doctor relationship. And the patient-specific knowledge that the doctor has will grow the longer that you see the doctor, right? Now, like this is what I was kind of alluding to earlier. As the relationship grows between the doctor and the patient, the doctor obtains a stronger and stronger ability to extract the net benefit from the patient through combinations of higher price and higher quantity. So that's not really a good thing for the patient. It's good for the doctor, right? They can make more money, but that's not really a good thing for the patient, right? So in addition to McGuire's model being able to sort of account or incorporate this type of relationship into the model, it also allows us to sort of alleviate some concerns about calculating consumer surplus, okay? And the main issue is that if doctors can induce demand, meaning they can push your demand curve around, then it's not very easy to nail down consumer surplus, right? If the doctor can just push your demand curve to the right very easily, well, then how do we calculate consumer surplus, right? Do we use your original demand curve or do we use the demand curve that was induced by your doctor? It's not exactly clear. But with McGuire's model, that's not an issue because the induced demand isn't really taking the form of your demand curve moving around. It's just them prescribing a quantity and extracting some of your consumer surplus. So that's another nice result of this model is that we can still calculate accurately consumer surplus, even if induced demand is a possibility, right? So it incorporates induced demand and it still allows us to calculate consumer surplus. It does require some additional modeling compared with sort of the simple competitive equilibrium approach, but it's like with all models in economics, right? If we want them to be more realistic, they're going to be less simple. So it's a trade-off, right? But I think in this case, it's a benefit. It's the net benefit of the trade-off is worth it, right? The loss of simplicity and the increase in realism is worth it, right? So McGuire's model is really incorporating all of these things we're observing, right? We observe induced demand. His model takes care of it. And it still allows us to carry out welfare analysis, right? Calculate consumer surplus. So McGuire's model is kind of the currently accepted way of looking at the physician firm. Okay, there's still this issue of quality, right? So we haven't said anything about quality so far. So let's try to add quality into this picture, right? And Dranove and Satterthwaite, in the same year as McGuire, in fact, came up with a more complicated model that incorporates the effect of both quantity as well as quality, right? So this is a nice extension. And again, it's going to be more realistic but less simple, right? And in their model, they have quality has two characteristics in their model. So there's clinical quality, which is things like how long is your visit, how good is the doctor's bedside manner, how clean is the office, right? Those sorts of things, things related to the clinical aspects of the visit. And then there's the patient amenities part, right? So like, how nice is the waiting room? Do they have televisions in the waiting room? Are there magazines that I can read while I wait? Is the receptionist a really nice person and pleasant to interact with? Those sorts of things, right? So they break quality into those two different categories. And each of those types of qualities basically has its own marginal cost structure. So that's pretty cool, but it is more complicated, okay? So they basically have a cost function, so a cost of production, that depends on three things. It depends on the quantity, which is the number of visits. It depends on X, which is the clinical quality, and it depends on Y, which is the patient amenities. And then the marginal cost function is a pretty simple linear combination of these things. A, B, and C are just coefficients. So, we would have to calculate these things. And then X and Y are the clinical quality and the patient amenities, respectively. Something else that they do that's really nice are able to define elasticities of demand for doctors, similar to the standard price elasticity. So they have several elasticities, so visual one. So eta P, the traditional price elasticity of demand. But then they also have elasticities for these levels of, they have eta X for the clinical quality elasticity, eta Y, which is the patient amenity elasticity. So how are to these changes in quality or these differences in quality, right? So aren't just responding to changes in price, they're also responding to quality. And among these two different types of quality, right? And they use a monopolistic competition frameworks, surprising. And they allow for various responsiveness. And so there's a couple of cool things we can calculate from their model. The calculate is markup. So markup is the amount that price is above marginal cost, or that markup is. How high is the price above marginal cost? Or what is the difference between price and marginal cost, in other words? And that is mu, and it's calculated as the price elasticity divided by 1 plus the price elasticity. So that tells us the markup, and the equilibrium price is given by the markup times marginal cost. So I guess in this case, it's not the difference, it's the percentage above marginal cost. So a slightly different definition, but still markup. So as an example, a numerical example, if the elasticity of demand is negative 2.5, right? So eta P is negative 2.5. We can calculate, oops, that's supposed to be eta. Kind of looks like an M, I guess. Eta is negative 2.5 over negative 1.5, which is basically 1.6 repeating. So that's the markup. So what this means is that price is going to be 166% of marginal cost. And that's exactly what this second equation says, right? So price is 66% higher than marginal cost, in other words. So 66% markup. Now, the most interesting part of their work defines how equilibrium quality characteristics come into being. So how does this issue of quality come into equilibrium, right? So they have some nice equations for that as well. And I'm not expecting you guys to memorize these things. You might have a problem that involves these, but of course you can always go to your book or go to your notes and look at these. You don't have to memorize these, okay? But they're able to determine equilibrium quality levels based on this equation. So for X, which is the clinical quality measure, the equilibrium level of quality for clinical quality is given by eta X by the price elasticity of demand. And then that is divided by B over P star, which, oh, B is from the cost equation, right? Let me go back to that real quick. Where is it? Is it? Yes. B is from, so this is B, right? This is where B is coming from, the marginal cost equation, and then C as well. Let's see, where were we? Yeah. So that's the equilibrium quality level for clinical quality, and then there's something very similar for patient amenities. And we can get a little bit better view of this picture if we do some algebra. So thinking about clinical quality, if we rearrange this equilibrium here, we get this equation here. So B times X star divided by the marginal cost equals this. And so basically this first part of the equation is giving us the proportion of total marginal cost that comes from clinical quality. So of the total marginal cost, how much of it or what proportion of it is accounted for or is due to clinical quality? And then there's a similar equation for Y. It's basically, you just rearrange this in the same way to get this equation here. So that can be useful. And basically what those rearrangements, those algebraic rearrangements are telling us is that the more that consumers respond to quality and the less that they respond to price, the more emphasis the physician firm will place on high quality. And so let me ask you guys this. Why would there be less responsiveness to price, given what we've learned in the past? Why would consumers be less responsive to price? Think about the RAND study, the RAND health insurance study. Yeah, Blythe, go ahead.
If they had health insurance, then it doesn't really matter because they have like the minimum copay that they would pay. So if it's more than that, insurance would just cover it.
Yeah, exactly. So we learned that insurance reduces the consumer's responsiveness to price because they're only paying a fraction of the price, right? That's exactly right. So chapter 4, right? Traditional health insurance makes consumers relatively insensitive to price. So what that means is if their model is accurate and we have these insurance plans that make people insensitive to price, then we should expect doctors to focus a lot on quality. Now, what we're going to see in chapter 11 later on is that HMOs and managed care insurance basically replaces the consumer search efforts with centralized insurance companies searching for low prices. So that's another interesting aspect related to this here. But we'll look at that more in chapter 11. But also, ultimately, this model directly predicts that physicians will put less effort into producing quality under managed care, right? Because the patient isn't doing the searching, it's the HMO or the insurance company. And so in that case, the physicians are not going to care about quality. But when it's a traditional fee for service, they will put more emphasis into quality, right? Okay, we're almost done here for today. One other thing that we will also see in Chapter 11 is that there are some new models of physician compensation that directly incorporate quality into the price. It's called fee for performance. And this new approach presumably offsets the downward pressures on quality that managed care insurance creates. So the idea is to incentivize high levels of quality under these new fee for performance types of compensation. All right, nailed it, right on time. Okay, so next time we will wrap up this this search issue, right? Matching of doctors and patients. We'll wrap up that section and then we'll move on to some other issues. So consequences of incomplete search. We'll look at actual search by patients. So we'll look at the evidence and see what the evidence has to say. And then we'll move on to some other issues, right? So we'll move on to the issue of advertising and the cost of information. We will look at the role of licensing. We'll look at the estimates of the demand curve facing physician firms. And we'll talk about induced demand and the role of different payment schemes. All right, so that's where we'll head next time. And hopefully we'll wrap all this up on Monday. But if not, we might have to bleed a little bit into Wednesday as well. So, but hopefully we can wrap all this up on Monday. All right, let's see. Any questions, anybody? All right, cool. Let's see. Don't forget, you got a homework due on next Tuesday. So be working on that. And I will see y'all on Monday. Okay, bye.